quick. I uploaded the new thing, I promise. What are you guys seeing right now? Hopefully, are you seeing, I picked the right thing. Are you seeing Canvas or what are you seeing? Anybody help me out real quick? I can't really tell with my two monitors here what I picked. Somebody? Can you guys see Canvas? Anybody? What has happened? Did my Wi-Fi just die or something? All right, let me back out. Nobody's gonna help me. What the hell happened? All right, I think I'm picking the right, yeah, I am picking the right thing. Okay, so I'm gonna keep going as if you're all there. As promised yesterday, I updated the homework timeline sheet one more time. This is the last time I'll do it, I promise. So this should be, I'll get out of there. Just open. Why can't I just open you? All right, let me see. Anyway, so you can go here. I want to open you. I shouldn't have to save it. All right, stop sharing. This is fine. This will give people a little bit more time to get here. Let me pull it up here. Okay, I like it. All right, where are you? Why are you not here? Okay, I love it. I love it. You're right there. Why can't I choose that? Let me see. I cannot choose that. There it is. Okay. All right. So I'm going to assume you guys can see the updated homework sheet.
Yes.
Okay, thank you. So this is it. This is the last time I'll change it. So I changed those next two quiz dates. I decided not to do the like general quiz I was talking about. You can see it's missing now. I just don't see the time for it. I did build in 2 review days for the final exam. So I will have a practice final exam and we can devote our time looking at those 2 days, plus doing whatever problems you want to do on top of that. So just in case you're wondering, yes, I do a practice final exam too. All right, let me see. Any questions you guys have from homework? Anything? I'm sliding down the mountain. Okay. Everybody's good? Everybody's all right with homework? Okay. Let me see. Let's do this. All right, let me come back here. Gather. All right, so let me change this up. So let's get back into, if there's no questions, let's get right back to where we left off last time. We had just gotten into what to do about 2 terms, right? So let me see. Okay. So just to review, what we did last time was something like this. Okay. And I tried to explain it to you using the method for 3 terms, realizing that there's kind of a 0 in front of the missing second term. And then I made a shortcut. The shortcut is, are each of these something squared? X squared is obviously x squared. And 100 is what squared? 100 is what times what?
10 squared.
Yeah, 100 is 10 squared. So I can break them in half. X squared, I put 1 there, 1 there. 10 squared, I put 1 there, 1 there.
Minus. Yes.
Yes, okay, I like it. Let's see. Okay, good. And then, do you see how I get x squared? X times x? X squared. 10 times 10? 100. So all I need then is for everything else to cancel. And just to make them cancel, I just make them different signs. Minus 10x plus 10x. Cancels. So that's the shortcut for difference of squares. When you have two terms, it can only be squares or cubes, and we will talk about cubes today. And if it's squares, cut everything in half, plus minus, minus plus. Just make the signs different in the middle. That'll make the middle terms cancel. Okay. Let's try one that's more involved. Let me leave that one up there. So what about this one here? 9y squared minus 49b to the 6th. Let's change things up a little bit. Let's see if you guys can really latch on to what I said. So this is the answer up here. Is this the difference of squares? There's two terms, no GCF. Can you cut each of these things in half? I'm not sure if you really understand what I mean when I say in half.
3 and 3 for 9.
Yeah. So each thing, 9 is 3 times 3. Y squared is 2y's. Right, so you can do y. 49 is 7. What do you get when you cut this in half?
B cubed.
B cubed. I love it. Right? So then, since I can cut everything in half, I do. 3y is 9y squared. 7b cubed, 7b cubed together makes 49b6. And now, just to make sure the middles kill each other, because they don't have a middle term, make these opposite signs. Okay. So it's kind of nice. In mathematics, we want to know why something works. But then once we know why something works, we can develop shortcuts based on the idea behind the thing. So that's the ultimate shortcut for squares, is that. Just cut everything in half. So what about this one? What do you got, Jeff? I don't know. What do you got? It doesn't matter. There you go, buddy. What do you guys think? Is this in the right form? Can you cut everything in half?
I'm not sure we can cut the second term half.
Beautiful. Why not?
Because 5 is 5.
Yeah. How do you cut this thing perfectly in half without using funky ass exponent? You can't. So what's got to be true about the exponents then if it's going to be a squares? All the exponents have to be what?
Even number.
Even. Yeah, even numbers are the only ones you can cut evenly into 2. I like it. So this is prime. There's no GCF, right? But what if I made the problem? So here's another problem, a separate problem. So if I made it this, now can I do it? Would be really creepy.
Yes, we can do. We can cut these two terms in half.
Yes. So the quick way, you guys need to know squares. You need to be able to identify square numbers. 36, 25, 49, 64, 81, right? Even 121. Anyone know what squared is 121?
12.
12. No. 12 squared is 144.
Oh, 11.
11. I like it. All right. So I know Yangsha's here today. Let's see. So you guys need to know your squares. And then the exponents have to be even because the whole idea is to cut it in half. So I'm thinking backwards. I'm thinking backwards when I factor. What would have been here and here to make this? The easiest way to do that is to cut it in half. Sorry.
5,
What's up?
5W. 5W.
Yeah, 5W. I'm with you. And then 81A10. 81 is
9A.
99. A5. And so I do get my 25W squared. I do get my 81A to the 10th, right? You guys, everybody see that? So I just need to make sure that the middle terms kill each other. Everybody mute yourselves, please. Okay. No? Okay. Okay, I like it. I like it. So you guys try this one. I'm going to give you one that's not freaky. It's pretty straightforward. You guys try this one real quick. What is it, Jeff? Sure. Do this one here. That look really creepy in the shadows. Do it. All right, so what do you guys get? Is it the right form? It's 2 terms, no GCF. I can cut everything in half. So then I do that. M is m squared minus plus. What's this going to be?
9 minus 9 positive 9 A is W.
I like it. All right, cool. So squares kick so much butt. They're so beautiful. I kind of call them a thank God problem or a thank the flying spaghetti monster, whatever your favorite deity is, right? They are awesome. If you can identify it as being squares, it's easy. So let me show you. I'm going to do this one with you. All right, don't freak out. I just want to show you. What we got, Jeff? Isn't this yummy? No. Let's see what else do I have here. Let's do, it doesn't matter. Let's do, yeah. All right. So the steps you take, oh man, change it. I don't want this to be anything weird. It's already weird enough, right? Change that to 25. Just make it 25. I don't want anything else. Is that all right? Just change that to 20. Of course it's all right. I made the problem. I could change it. The steps you take are, is there a GCF? No. Right? This is 5s, and that's even. There's no way. Can everything, there's 2 terms. So I know it's either squares or cubes. Can I cut everything in half? Yes. Right? All the powers are even. That's a squared number. That's a squared number. Right? So this looks disgusting, but it's easy. Gotta make a little bit bigger stuff here. 144.
12.
Good. Then I just cut these in half. I put half of them there, because when I multiply, they become whole again. Oh. Right? So I get
W4.
Just keep going. It's Y 5,
5,
D
20.
20. So W4, Y5, Z20, plus minus
5,
5.
A3, A cubed, B9. That's it.
There you go. Why does it make sense? Because half and half is whole. Half times half is whole. Plus this minus that cancels. It's so awesome.
What's the exponent on B?
On which one, sorry?
On B at the end?
9 and 9.
At the top.
18.
Yeah.
Yeah, see that? Freaky. Okay. 18. Okay, all right. Now, take this away. Let's do this. Now watch this. Here comes something interesting at you. Let's see, what do I got? Oh yeah, let's just do this. Sorry. You can do it, Jeff. Oh, shoot. That's right. I want to make this. Sorry. Make that like that. Okay, now, write that down. All right, now, somehow this relates to what I was just talking about, but forget about that for a second. What do you look at to tell what to do? What do you try first?
BCF.
GCF, I love it. And this has no X's, that's a 5, and that's nothing, right? Sorry?
Grouping.
Good, good. So after GCF doesn't work, you try to see how many terms there are. There's 4 terms, so I'm going to do grouping. What comes out of these two?
2x.
Yep, x squared. And I'm left with 5x, right? Minus 7. Took those x squares out. What comes out of these two?
-4.
4.
Good. -4. Because they need to make this positive so it matches up with this one. -4. So then if I take -4 out, -20 divided by -4 is 5x. 28 divided by -4 is
7.
-7. Because I took a -4 out, right? And then I can do what normally would be the last step. I can take 5x minus 7 out, and I'm left with x squared minus 4. But why are you not done yet?
Oh, because we have the x squared minus 4.
You have a difference of squares. So every problem you do is factor completely. Don't stop too soon. Just take a minute. When you get something done, you take a quick minute, you see, is there anything else like, oh, this is the squares. Okay, so this guy just comes from the ride. How do I factor this guy? This is a nice one.
X twice.
X minus plus 2. So you can't stop factoring until you get everything at factors as much as possible. Okay. So the point I'm trying to make is the minute we learn a factoring method, it could show up in other problems, right? At the beginning of this didn't look like anything like a squares. It didn't look related to squares at all. And I don't have to worry about at the beginning how many steps it's going to take. I just do what I can see. And then when I'm done with that, I say, okay, am I really done? Oh, shit. Right?
Can you repeat the third step? The third
The
step?
fifth step?
Yes, please.
So these are the same. So they can
Yeah.
come out.
Oh, okay. Yeah.
And I'm left with x squared.
And
minus
4.
Yeah.
And the last one?
And then we notice that this is a difference of squares. So I can cut everything in half.
Okay.
Yes.
Why we carry the half?
Say
Like, okay, I got it.
Yeah, that's the thing we've been doing. But I just want to show you it could show up in a different kind of problem. It's just after you finish doing something, I'm done grouping here, right? Don't just circle it. Just say to yourself, is there anything else I could do? Oh, all right. And then do that part if there is. If there isn't, then you circle it.
Okay.
Make sure you go all the way.
Thank you.
You're welcome. Okay. All right, let's see. So, here comes some freakiness. So let's talk about cubes. Right? So if I had something like this, x cubed minus 8, right? Sorry, some of you guys are doing some weird stuff. I might think maybe a similar thing will work here. There's nothing wrong with thinking maybe something similar to squares will work here, right? And so this is obviously not squares, but it is cubes, because what is x cubed? It's x times x times x, right? And what's 8? 2. 2 times 2 times 2. I love it. So let me try to dispel this notion that the answer is something like this. So I have people that tell me the answer is x minus 2, x minus 2, x minus 2. Or even put a plus in there somewhere or something, right? I don't know. This is the wrong answer. This will not work. And I'm just going to real quickly show you why. If I multiply these together, I get x squared minus 2 at minus 4x plus 4 times x minus 2. And if I multiply these together, I get x cubed minus 2x squared minus 4x squared plus 8x plus 4x minus 8. Is anything going to cancel here? I'm not meaning for you to copy all this down. Don't copy it down. Don't. Just stop yourself. I'm just trying to show you how this is not the way this is ever going to work, because do you see how it's missing an x squared and an x term somehow? They both canceled somehow. The same way that the difference of squares was missing the x piece, the middle piece. Are you guys with me? So this will be more complicated. It just will be. Not a lot, but just enough to freak people out. So this is not the answer. Even if you put some pluses in there, it ain't never going to work. All this shit's never going to cancel. So I give up on that. So maybe, and this is what actually works. Let's just cut to the chase. So what if it's this instead? What if it's, so make a little dude and a big dude for me real quick. All right. Right? Little dude and a big dude. Do you see that? So in the little dude, I'm going to put one of these X's and one of these 2's. Let me stop for a minute. Now with squares, I would just put another X here and another 2 and I'd be done with it, right? But I have cubes here. How many more X's have to go here?
X squared.
Yes, because that's the only way I can get X cubed.
Yes.
And how many more 2's have to go here?
4. 2.
Yeah.
Positive 4.
2 times 2, 4.
Yes.
Now watch. Now stay with me, stay with me, stay with me. You'll see why in a minute I've left room. Hopefully you have too. Something else has to go here, and I want to show you why. So let me see. Let me do it this way. When I multiply this out, I get X cubed, right? And I get minus 8, don't I? So what's my problem? Well, I also get negative 2x squared, don't I? And I also get 4x, don't I? Do I want those? I really want you guys to be with me. So if I stop right here and I say, I think this is the answer, let me check. And I multiply that out. Did I get x cubed minus 8? No, I got extra stuff, didn't I? Yes? So now watch. So I left some room in the middle. And this is for the people that ever watched Pulp Fiction, real quick. Have any of you ever seen the movie Pulp Fiction? It's just out of curiosity.
Yes.
It's not a necessity. You don't have to have watched it. In fact,
Yes, I have.
Huh?
I have.
I like it. Nobody else wants to tell me. It's okay. You can keep that to yourself. I didn't realize it was a personal question. There's a part of the film which is not generally appreciated, but it's the part with the guy in the back seat and they accidentally shoot him in the head. And they have to call this special guy to come out and clean up the mess. So I call this guy right here. I don't call him the wolf. That's what it was in there. I call him the cleanup guy. He cleans up all this extra stuff I don't want. So now watch. What would I multiply x by? Let me see how I want to say this. Yeah. What would I multiply x by to get negative 2x squared?
2x.
I'm sorry, positive 2x squared. Yeah. So plus 2x, right? Wouldn't that make x times 2x? I really want you guys with me. I just put a new term here, right? So I better do x times 2x is positive 2x squared. That cancels that piece. That's good. I don't want that piece. But watch what else happens. What's negative 2 times 2x?
Yeah.
That cancels that piece too. I don't want them. So this is definitely more complicated than squares. We knew that going in. It was going to be a little more complicated than squares because instead of 2 of each, I got 3 of each. And instead of one thing having to cancel, I have 2 things that have to cancel. But I want you to realize something, all right? 2x, isn't that 2x? That middle term will always be this times this.
Mm.
All right, let's do another one. Let's do another one. So everybody got what they want from this? More than you ever wanted. I understand.
And the down is a positive 2.
Again, sorry?
And down,
Yeah, it's a
the
plus.
last one. The last one. Wait. Yes. So yes, it's positive 2.
Yes, definitely, because that would be x times 2x is 2x squared. And that cancels with those, right? Okay, all right. I'm gonna erase. It's going away.
Right.
Okay, so let's try another one. Y cubed minus 27. Okay, can't stay with red. Sorry, red. Oh boy. So it's 2 terms. It's definitely cubes. Y cubed is y times y times y. 27 is
3.
3 times 3 times 3. I put a little dude and a big dude. So whenever I see cubes, it's going to be a little dude and a big dude. The little dude is just a little dude, man. You can only put one of each in him. It's a little tiny dude. So I'm going to put 1y minus 1, 3. So then how many y's have to go here?
2.
Yep, y squared. And at the end over here goes the other 2 3's.
9.
So see how I get my y cubed? And I get my minus 27, don't I?
Yes.
But then I need that middle term to kill all the extra stuff I would get. Right? I would get 9y, wouldn't I? 9 times y, I would get 9y. That's extra. I don't want that. And I would also get minus 3y squared. I don't want that. I need to kill those. So what's going to go right in the middle here is going to be the opposite sign. Why? Because I need them to cancel the other stuff I don't want. So it's always the opposite sign. And then whatever these are, 3y. Slam them together. So watch what I just got by introducing that new term. I just got minus 9y, right? Minus 9y, dead. And I got plus 3y squared, dead. So this makes y cubed. This makes minus 27. This cancels all the extra crap. Why was squares easier? Because it's perfectly symmetric. One of each, one of each. This is one of each, two of each. Does that make sense? 1y, 2y's, 1, 3, 2, 3. So they're not balanced. It's going to have to be a little bit more difficult. All right, let's try another one. All right, Jeff, calm down. I'm sorry. I'm going to erase this. Go away. All right, let's do this. How about, let's try a plus here. X cubed plus 64. Now, 64 is a really funky number. 64 is 8 times 8. But is this a squares? Can I cut that in half? No, not nicely. 64 is also a cube. Anybody know what it is? What times what times what?
4.
Good. 4 times 4 times 4 is 64. That's a neat number. Math people geek out about that shit. It's a square and a cube. Like, ooh. All right. So, I like to write this for myself. X cubed is x times x times x. 64 is 4 times 4 times 4. It's a cube, so I'm going to put little dude, big dude. What goes in that little dude?
X plus 4.
Yeah, 1x plus 1, 4. And then the other 2 x's go here. The other 2 4's go here. So see, I get 3 x's and 3 4's, right? What's going to go right here? What's the sign going to be?
Subtraction.
Minus 4.
Got to be the opposite sign so it can do its job. Its job is to cancel stuff, right? So it's got to be the opposite sign. And then it's just
4x.
4x. And then you can check it. You can multiply it back out. But sure enough, that cancels all the extra crap you get. And so you're only left with x cubed plus 64 because that will cancel the other stuff you get. That's the problem with any other thing you might think is the answer is you always get extra stuff that doesn't go away.
Okay,
the
now
only way to
what,
make it. Sorry.
okay, now what we do now? After
You
that.
circle it and you say, give me another one. Here's the neat thing. I think this is what you might be worried about. I don't know really if this is what you're worried about, but this guy, the big guy, can never be factored. The big guy can never be factored. The middle term is always half what it needs to be factored. Do you have to know anything I'm saying right now? No, but just in case anybody finds this interesting, if it was x squared minus 8x plus 16, I can factor that. And notice how it factors. Very interesting. But the big dude will never be factorable. The middle guy is always half of what it needs to be. So unless there's a GCF you left in there, you're done at this step. That's the one saving grace of these weird ass cube problems is you're normally done in one step. It's kind of a big step, but you know. Ooh. Okay, let's try another one. What time we got? All right, we got time. Let's put a little more stuff in here. Let's see. 8w cubed plus 27. Let's make this more interesting. Y to the 6th. I like it. So the question you ask yourself when you see two terms, no GCF, can I cut everything in half or can I cut everything in thirds? And I mean multiplicatively, right? 8 is 2 times 2 times 2, but it's not a square. What about, and this one you could obviously cut in thirds. 27 is 3 times 3 times 3. What do you get when you cut this in thirds, of course?
3y squared.
Y squared, Y squared, Y squared. So I can write down for myself, 8w cubed would be 2w times 2w times 2w. Is that cool? That's what 8w cubed is, cut into thirds. This would be 3y squared times 3y squared times 3y squared. And then I can build. I can build what I need. I got my little dude and my big old dude. What goes in the little dude?
2w plus 3y squared,
Good. 2w plus
3y squared,
3y squared. I like it. And then what goes here?
2w squared,
No?
4w squared,
Yes. And then let me skip this for a second. What goes at the end here?
9y squared,
Want 9y.
Adam, 4,
There you go. We know what to do when we multiply, right? This is all multiplied, right? So if I have 2 y's there, the other 4 have to be there, so I get 6 altogether. You can kind of keep track as you do it. Am I getting what I'm supposed to get? What will the middle term be? What sign will it be?
Opposite sign.
Good. So minus. Multiply these. So the middle term is always this times this. Opposite side. 2 times 3 is 6. WY squared. Done. One of each, 2 of each, product in the middle. And here's a little extra something that I don't really love, but I'll just show it to you. I think the more, you already know how I feel about FOIL, for example, but this is a little less. This sign is always the same sign. It's always the same. It's S for the same. It's always the same sign. This is always the opposite sign. And this one is always positive. So what do you get? Soap. And I love that it goes along with my cleanup idea. This guy is a cleanup guy. He's going to need some freaking soap. All right. I don't know if that helps anybody. The basic idea makes sense. I have 3 of everything. If I put 1 of each here, I must put 2 of each there. So I end up with 3 when I put them back together. This middle term is the freakiest part of this whole thing, but I need him to kill all the extra middle terms that I don't want, that can't be a part of the answer. Okay, all right. So what about, let me give you one. There's a lot there. I don't know if you guys finished. Have you guys got all this? Yes, okay, it's going away. So how's about this here? What will save you? People will start, they'll do a little dude, big dude. That is completely wrong. Is this a cubes? Is this a difference of cubes? No. Look at this thing. You can't break that in 3 pieces. What step did you skip? That will always save you from making really silly mistakes. What do you always try first?
GCF,
GCF. So what comes out?
2.
2.
X.
X. 8 divided by 2 is 4. I had 3, took 1, so I have 2 x's. 2x divided by 2x is 1. Can anyone see? What'd you write, Curtis? I like that fractor. I like. Can anyone see that I'm not done? What's this?
2 square.
The difference in squares. Yeah. So 2x comes for the ride. I can cut everybody in half, so I do it. What's 1 cut in half? 1, 1.
1, 1.
Change the signs, and I'm done now. Yay. So don't just see this and say it's a cubes and put little dude, big dude and start forcing things in. It ain't a cubes. You can't cut everything in thirds. In fact, a really quick one, if I have 9y6 minus, in fact, I did this earlier, I think, right? Didn't I? 25w4 x3. That is not factorable. Just that one thing kills the whole thing. Can I cut everything in half? No. So it's not squares, and it's not anything else. There's no GCF. It's prime. This is prime. It just takes one little piece to be off. Okay, maybe. So this wasn't cubes, but I could still do a GCF, and then I said, holy shit, it's a squares that was hiding. It was hiding underneath this 2x thing. All right. I want to show you one more thing, and then maybe we can leave early today. Let's find out. It's a little thing about squares real quick. I want to show you. All right. First step, there's no tricks, but then you got to be careful. And I gave this away. I told you it's squares, right? This is definitely squares. I can cut everything in half. So what would it be?
X squared.
X squared, I like it. Minus plus or plus minus
9. Y
9
squared.
y squared. This is a point that I haven't made yet, come to find out. I didn't even realize I haven't made this point yet. Can I factor this further?
Yes, yes.
Can you cut everything in half? Yeah, it's a difference of squares. What about this one?
Same, yes.
No. This one will not factor. And I will explain to you why this won't factor as we factor this. This one will factor. So why does this one work? Because how do I do this one? And of course, this guy's just going to come for the ride. He just comes for the ride. But let me explain why he's not factorable. You cannot factor a sum of squares. Here's why. X squared, x. 9y squared, 3y, right? And then I put minus plus. Why do I need that? Because then the middle terms can cancel. Why are they allowed to be opposite signs? Because they multiply to be negative. So if it's a sum of squares, you can't do that. You can't break this up. You can't put x plus 3y, x plus 3y. The middle terms won't cancel. So that one, you cannot factor a sum of squares for the exact same reason that you can factor a difference of squares, because the minus allows you to have different signs. So that's why you'll see a reference to sum of squares. And then you'll see a reference to sum and difference of cubes. Cubes can handle that. And I want to kind of explain real quick why. So what is -2 squared?
Four.
+4, right? What is -2 cubed?
-8.
-8. So even powers. squares, lose if it was negative or positive. Odd powers don't have that issue. That's why odd powers can handle plus and minus, whereas even powers can't. Right? You can only factor a difference of squares, but you can factor a sum or a difference of cubes. And it's related to this fact here, that if I cube a negative, it stays negative. It doesn't lose information about that. Woo! That was a lot. All right. We actually just finished.
Professor,
Yeah, sorry.
this is chapter 7.4.
This is 7.4, which means we did 7.5 also. Remember,
Okay.
7.5
Okay.
is just a 7.1 through 7.4 all mixed together.
Okay.
Yeah. So don't forget, tomorrow we have a quiz, 7.1 through 7.3.
Was this 7-4?
This was 7.4, yes. So we just finished talking about 2 terms. So I'm not going to do a quiz at you tomorrow on something we just finished talking about today. That's going to be on the quiz next week. Tomorrow's quiz is going to be GCF, grouping, and then the AC method stuff and the other 3 terms, right? 7.1, 7.2, 7.3. Okay.
Thank you.
Anytime. I'm sure you don't mean that really, but that's all right.
Professor, I'm asking about my makeup quiz, you said? You remember?
Oh yeah, your makeup quiz. All right. You gotta I'm sorry. I've got a lot going on. So I'm still gonna let you do it. I just gotta make it. So somehow I've got to remember to make that and then let you know to do it.
Okay, thank you.
Just keep on me about it. All right. Anybody else have any other concerns, questions?
No.
If not, you could head out.
Thank you.
You're welcome. I'll see you tomorrow. Bye, everybody.
Bye.